Hello. In this section, we're going to take a look at program control and flow in the VisiLogic's program. And I have this, in my mind, sectioned into three areas. We're only going to cover one of those this time, but let's quickly talk about the three areas. If you're designing multiple HMI screens in a menu type system where you're doing 3 or 4 different things and you have an HMI interface for each one of those. Within the HMI design screens are links and jumps, tags, and you can run code when you start up the HMI screen or when you close it. That's mostly built for menu systems, not a very typical use in the automation and control field. The second way to deal with program control and flow is to jump to labels. That's a pretty straightforward and easy thing, but we'll create that and work with that on another video to give you a demonstration of how that works. And the final one is the traditional programming method of taking a very complex task, breaking it down into subroutines, and testing those subroutines and making sure they work correctly, and hopefully using them in the future for what's there. That's the one we're going to tackle today. So this is very specific to the VisiLogic software. The programming concept of breaking a task down into subroutines is pretty general, though. Okay, so what we're going to do is write a simple program to try and demonstrate this. It won't be practical. We're going to try and make something real simple so that you can see it. So my idea is to take an equation like 2x squared plus 5x minus 3, and we're going to solve for different values of x. We're going to let you enter the x value to solve for in an HMI screen. We're going to hit a button and we're going to find out the y value for that x number, and then we'll let you do that over and over again. And what we're going to do is take that equation and break it down into parts. We're going to call them part 1, part 2, and part 3. We're going to write a subroutine for each of those parts. So the 2x squared part is going to be part 1, and a subroutine is going to solve for that interim value. And the second part is going to be called part 2. We're going to write a subroutine for the plus 5x part. And then finally, we're going to have a subroutine for the minus 3 part. And obviously, I could do this many other ways, a lot simpler without subroutines. But as we said, we're doing it for an example to show you how to structure these things and build the program. Okay, the other thing is that as we go along here, we might use some new instructions that they're pretty common things. So we'll be introducing those instructions as we go along too. So I have a new project up here, and I have the subroutines as they start. By the way, this under the main module, there's a main routine and there's an asterisk in front of there, and that just means that's the routine that runs by default when the power is applied. Okay, same way with the HMI screens. There's under the startup module, there's a startup display that has an asterisk in front of it, and that just means that's going to be the HMI display that starts out. So we're going to use multiple subroutines and only one display. So for the main routine, I'm going to change the name, but I'm always going to leave that asterisk in front of there so I know which routine is going to start up. So if I just go in here and right click on here and say rename, as I said, I'm going to leave the asterisk there, and I'm just going to call it main, just to sort of show you that you can change the name. Okay, the other thing that I'm going to do in preparation here is create the subroutines for part 1, part 2, and part 3. So if I right click on here and say add new subroutine, that's going to be part 1, and I click off of there, and that created that. I'm going to add another new subroutine that's called part 2, and you can see that this PLC world actually, helps you structure when you write a program and you have to write command lines and different lines in there. You got to make sure that part of the code doesn't execute, and there's a bit more to the structure. Here, it's just the very simple thing to create more subroutines. By the way, a subroutine has to be a separate module. So you can't combine and call subroutines from in one of these subroutine modules. You have to create a new one for each area. So when I go to main, I'm not gonna go elaborate with the comments in here, but I do have a final version of the program that will become available to you. So we're just gonna say main routine that calls all the subroutines, and normally I would put a lot more detail in there, especially if I'm using it for learning. So I have that comment here, and all I really have to do in the main routine is call all the other subroutines. And a PLC program sits out in a loop, so I don't want them to run all the time. So I'm going to create a switch, and that switch, let me switch over to operands and memory bits down here. That switch is going to run the subroutine. So on my HMI interface, I'm going to enter a place to enter an X value in, and then I'm going to have a button below that. I hit the button, and it's going to put that X value in the formula, which means it's going to run all these subroutines, get a value, and get a final answer. So, thinking ahead to doing that, giving you an idea what the program here is, I'm only going to run these subroutines on a negative, on a rising edge. So I'm going to drop that instruction in there. I'm going to use the first next use bit, and I'm going to call it execute subroutine switch. And obviously people can come up with their own useful names. This one works for me, and it's there. Now I'm going to want to do each one of these subroutines from this same switch, so I can copy this. If I click on the right part and say copy, and I can come down here and say paste and put that there, and do the same thing down here. So I got 3 of these switches because I got 3 subroutines to run. Next thing I had to do is I created the structure for the subroutines. I gave them names. Now I have to call them when I want to. I didn't write the code yet, but we can call it anyway. We can get this set up to do it. So in the main subroutine, I'm just going to call the first part, the second part, and the third part. I'm going to call them in that order, and it's going to keep values as it goes along. So I'm going to click on this call subroutine function over here. I'm going to drag it up here, and you can see the window that comes up wants me to pick which subroutine I'm going to call. I'm going to call part 1 first, and then I'm going to do the same thing for this part 2 subroutine, and I scroll down there a little bit, do the same thing for the part 3 subroutine. So I got all those set up, running and ready to go. I just don't have any code yet. So let's go back up here in the comments. I'll expand that down a little bit so that you can see it. And remember that we're going to implement 2x squared, right, plus 5x minus 3. That's what we're implementing. And the first part is going to do the 2x squared, the second is the 5x, and the third is the 3. And the plus and minus is going to be taken care of as the program runs along too. So let's go to the part 1 subroutine and start to put some code in there. So I click on part 1. You can see the screen clears out like I'm writing a whole nother program, but I'm writing a subroutine, right? And we probably should put that at the top. Part 1 subroutine and I'm going to do 2x squared. And I probably told you there's much easier ways to do some of the stuff. We're just going to do it here for the example of setting up the subroutines. So I have to get my x value, have to have a place to store that, and I have to choose a data type when I do that. So I'm going to choose memory long, so I don't have to worry about whether I'm exceeding a value or not. Got a lot of bits in there, big range of numbers, and we're going to take our x value, so and we're going to do that. So we're going to multiply it, or raise it to the second power, which is multiply it times itself. So if I go to the math instruction and I get to multiply, once again, this is one way to do it. We're sort of trying to not use too many complex instructions. And instead I'm going to do a memory long, and I'm going to pick my next use location, and I'm going to say x value. Let me do the caps. Hitting the wrong keys here. Sorry about that. So memory long 0x value to solve for. So this is going to be the x value that's entered in by the person from the HMI interface. So I click OK, and accidentally ended up doing both of those. So x value to solve for, that's what I wanted to do anyway, multiply it by itself. And now I'm going to have a place to store that result. It's going to be sort of temporary. So I'm going to do another memory long, and I'm going to pick the next use. And temporary x results. So that just means in the interim when I'm working through the equation, this is going to be a place I'm going to use to store the value. So I have x squared. I didn't do the 2 part, so I've got that there. So I got to multiply. So I go to the math instruction, pull down a multiply, drop that in here. And what am I going to multiply? My temporary x value. So I already have that. I'm going to do a memory long, and it looks like we're using ML1 to do that. So I'm going to say ML1, and I'm going to multiply it by a constant of 2. Okay, and now I have to have a place to store that. So no use wasting other memory locations. I can just use my temporary value. Remember, ML0 is what the person who's running the program on the HMI interface in, and that's the x value we're solving for. So here, we can just put it right in the temporary result, save it there at that point, and I'm done with this subroutine. I did the x squared and I multiplied it times 2, and I have the result stored in ML1. Notice, by the way, when you write subroutines or you create a new one, if I scroll the whole way down to the bottom, they put a return in there for you. So they've set the structure up for you, and that's there. So I have to go to part 2 now. So once again, I click on part 2 over here. I'm going to put a comment up here. And this is the part 2 subroutine. And we probably would want more comments in here to make sure it's there. But what we're going to do is do the plus 5x portion of what's here. So I already got this number partially done and temporarily stored. Now I want to do 5 times the initial x value and then add that temporary value that I've already gotten for the 2x squared part from part 1. So let's do the 5x first. Remember, x is the number that someone entered in. So we're going to do a math, and we're going to do multiply again. I'm going to drop that in here. And now I got to go back and find the value that someone entered in, right? If I don't remember that, I pull down here and it says x value to solve for. So hopefully it gave it a good enough name so that I can remember. Then I'm going to come down here and multiply it times 5, right? That's a constant. That's what the pound sign is for. And I'm going to click OK. And now I have to store that somewhere. And I can't store it in our temporary x value, right? So I have to have a place to hold this until it's here. So I'm going to do a memory long, do the next used, and say part 2 temp storage, right? And I'll click OK, and that's there. Now that takes care of the 5x part, but I have to add it to the current value that I have 2x squared, right? So I got to remember where I stored that, and I have to do an addition, right? So I get an add instruction, I put it down here in the next net, and now I have to come up with the two values, right? So memory long, if I forget what I've used or created so far, I have that temporary x result from part 1. That's the one thing I'm going to choose, and now it wants me to choose the other number I want to add, and that's ML2. I can see that right up here. My temporary storage from here, I add those two values together because I'm doing plus 5x, and now I have to store that somewhere. So if I do memory long, I look down here, and I can just right over top of the temporary x result and store that there. And once again, my subroutine's already, the return is already put in here by the software, and I'm done with part 2. Now part 3, pretty simple, right? I put a comment in there. I'll say part 3 subroutine, and this case I'm going to do the subtracting of 3. So that should be pretty easy, right? Do math, subtraction in here. The value that I'm going to use is the result that I've been working towards, the temporary x result, right? And I want to subtract 3 from that. So I got a constant. I put the value 3 in there, click OK. And now, where do I want to put that? And we have the x value to solve for. That's the one that the user put in. But I'd say this is our y result, and probably temporary x result wasn't right. It should be temporary y, but there. So I'm going to create another long, and I'm going to do next used, and I'm going to say the function result, and click OK. So that's what I'm going to want to display on the screen as a result. This takes care of the -3, and this ends this subroutine, and the return is already there. Cool. We're done with that, except now we need to have a place to enter the value and display that. So if I go to my HMI screen, I'm going to put some text in here first to design my window, and I'm going to say enter x value, right? And I don't really like this color, so I'm going to change it to something that's a little bit there. And I probably, you know, the style here, this pressed, I'm not entering anything in there, so I'm just going to make it transparent. I'm going to stretch this out a little bit so it's there, and we're good. And then, you know, it's just text on a screen. So we're going to enter an x value, and then I'm going to copy this. So I do a Control-C, Control-V, and I drag that down here. And I know I'm going to need another label for result. So that's going to come up here very shortly. While I'm here and formatting the text values to enter in, I thought I'd do that here. So we have to enter a value in. So I want to enter a number in. It's numeric, right? So I'm going to do that enter numeric. I'm going to drag this out here, right? And I'm going to want to enter something in. What I'm going to want to enter in is the Wow, can't click the right thing today. So long value, I come down here, and that's the X value to solve for. So I'm going to link that to that. Once again, I don't like this text color, so I'm going to change that to something a little bit more standard. And style-wise, I'm just going to make this a flat value. So someone's going to have to hit the keyboard and enter something in. So I got to check the keypad entry. I'm not going to worry about people putting values in too big or too low. We'd want to do that on a regular program. But we're just going to assume we know what we're doing. So I'm going to change the keyboard type to simple so we don't have a lot of extra keys in there, and click OK. So now when I bring this up on the screen, someone's going to be able to click that and have that running. Next thing I want to do is add a button, and that button is going to, once again, I don't like this color for the text right away, so I'll change that. And I'm going to put the text in there and say solve for f sub x. So when we hit this button, we want it to be triggered, and whatever value you have in the top is going to solve for that and put an answer in the result. So I have to tell it what memory location to be associated with. So I'm going to click touch. It's a bit location, and I've already set up this bit location, so I'll click on the down arrow, and it says execute subroutine switch, and that's exactly what we want. So now I have that associated with that. Now, the last thing we need to do is have a place for the result to show up. So that's also numeric, and I drag that out, and I'm just going to put a lot of room here so I can make sure my result doesn't get messed up. Once again, don't like the color, change that. And I'm going to link that, right? And that's a variable that was already created. You could create your HMI interface first and create all the variables up front, or you could create your code and create the variables as go along. Either way is fine. I'm going to pull this down, and it's the function result that I want to show in here. And I click OK. Now, there's some power-up things that I could sort of set to do this, but my whole purpose here is to show how to make subroutines and how to structure them and run them. So I'm going to click OK. I think I should be all right with that. Now, I think I'm ready to go. I got everything I want. I'm going to download this to the PLC. And we'll keep our fingers crossed that we don't get any problems. We thought of everything. It's not always, the thing when you start to write programs, you don't always get it right the first time. But I think it's downloaded. I wasn't paying attention to there. But I got something up on my screen. So let me take a look at that and give you a shot to see what's happening here at the same time. I'm going to enter a 7 in there. Okay, notice I didn't get a result yet. Now I'm going to hit the solve for f of x button because I got a thing in there, and this should solve for when this is a 7. So what? 7 squared is 49, times 2 is 98, 7 times 5 is 35. And if I add those two together, I get 133 minus 3. And I get 130, and that looks right. Probably not good to just enter one value in there, so let's enter another value in there, hit a 1 again, and I get a 2, and I'm going to put that in there and hit the enter key. Notice the result didn't change because it doesn't change until I hit the button, and I get 15. So 2 squared is 4, times 2 is 8. 2 times 5 is 10. That's 18 minus 3 is 15, and that looks pretty good. Okay, it ends up that troubleshooting is probably done better through the HMI interface. It's a very simple program, but I could come back through here and look through the subroutines and watch the code execute as I go along for part 1, part 2, and part 3, and also for the main thing. but there's not a whole lot of code in here, and I think we've hit the purpose we wanted for this video. So that wraps it up. I think that gives you a good idea of how you create subroutines and execute them in VisiLogic.